Okay, this is our third video for Algebra 2, Unit 4, Day 3, and in it we are going to discuss the laws of logarithms. Okay, so this first one we're going to talk about is called the power law, and we can easily see how it works just by using common sense. Okay, so remember, these are all log base 10. Okay, how do I know they're all log base 10? Because when there's no number here, right, we know to assume that it is base 10. Okay, so kind of a little mathematical shorthand there, a little abbreviation. Okay, so that said, looking at this first example, log base 10 of 10 to the fifth power. Okay, well, we know that's going to be log of, and then we're going to have one, two, three, four, five zeros, right? So we need to think 10 to what power is going to give us 100,000? Well, and the answer to that quite simply is going to be 5, right? And if we chuck this in a calculator, if I say, log, and we know it's base 10 of 10 raised to the fifth power, well, it's going to give me 5, right? Okay, let's do another example. Log base 10 of 10 to the second power, or log of 100. So we're asking 10 to what power is going to give us 100? And we, of course, know that that's going to be 2. 10 squared is going to give me 100, right? And again, if I check this in the calculator, log base 10 of 10 squared, also known as 100, is going to give me 2. Okay, so here we see another example, and we already know the answer to this. This is the exact same one that we did before, right? Except we don't have it written out as an exponential function. Okay, so we see that there's a pattern. We know this guy also is what we did before, right? So that pattern that we're beginning to realize is simply this. If I have log base b of x to the y power, right, and I'll use parentheses to kind of really be specific, okay, what we're going to always end up with is y times whatever log base b of x is. Okay, so this is the power law of logarithms. Okay, so for example, let's look at this guy again. So I have log base 10 of 10 to the fifth power, right? Well, according to this, I can rewrite it this way: 5 log base 10 of just 10, right? Well, 10 to what power gives me 10? Well, duh, 1. And 5 times 1 still is 5. And if I throw it in the calculator that way, if I say 5 times log base 10 of 10 to the first power, oops, where did my cursor go? There it went. Okay, I see I get the exact same thing as when I just left it as 10 to the fifth power. Okay, so that's the power law. So now we've got the product law. Okay, and we are being asked to evaluate these completely just in the calculator. And that's exactly what we'll do. Well, maybe not. How come I cannot? Let's just get out of this. Okay, there we go. Clear scratch pad. Okay, so if I just do log base 10 of 45. Okay, so log base 10 of 45. Okay, I get approximately 1.65. Okay, so this is about 1.65. Okay, let's do the same for log of 21. So because it's just log, we know it's just base 10 of 21. I get about 1.32. Okay, let's do it again. So I've got log 9 plus log 5. So log base 10 of 9 being added to log base 10 of, where did it go? 5. Whoops, not 105. 5. Okay, so that's going to be about 1.65. Oh, that's weird. We got the same thing here as we did here. Oh, let's look at another one. Okay. So log base 7 plus log base 10 of 7 plus log base 10 of 3. So log base 10 of 7 plus log base 10 of 3, 1.32. Okay, so here we get the same as we do here. Well, what is going on? Well, what we're seeing is the actual product law of logarithms. Okay, if I have log base b of x times y, right, this is the same thing as log base b of x itself plus log base b of y. Okay, so let's try another example. Let's do log base, who cares, 2 of 32 and see if that is in fact going to be equal to log base 2 of 8 plus log base 2 of 4. Okay, so let's see. Let's see how this works out. So I'm going to say log base 2 of 32. Okay, hit enter, we get 5. Okay, so log base 2 of 8 plus log base 2 of, where'd it go? 4. We still get 5. Okay, and that's because, well, duh, log base 2 of 8, 2 to the third power, right, gives us 8, and 2 to the second power, right, gives us 4, and 3 plus 2, of course, is 5. So this checks out. Okay, one last one, the quotient law. Okay, so this one is very similar, very, very similar to what we saw with the product law, except of course we're talking about quotients, right? So, give myself some room here. Okay, so we're looking at log of 6. So control log base 10 of 6. Okay, we get about 0.78. Okay, and then log base 10 of 4. So log 10 of 4. Okay, we get about 0.6. Okay, so now let's look at what we get here on this third example. So log base 10 of 12 minus log base 10 of 2. Oh, we get about 0.78 again. Same thing here as we got back here, right? Okay, let's look at the next one. So log base 8, or my bad, not log base 8, log base 10 of 8, right, minus log base 10 of 2. And we get about 0.60. Okay, what's happening here? Well, we got the same thing here as we got here, right? And we see that 12 divided by 2 is 6. We see that 8 divided by 2 is 4, right? So that gives us the pattern that we call the quotient law of logarithms. Okay, the quotient law of logarithms being if I have log base b of x divided by y, right? This is precisely the same thing as log of that same base of x minus log of that same b of y. Okay, and just to prove a point, let's go ahead and just come up with one. So let's say log base 3 of 72. This should be equal to, what are some factors of 72? 8 times 9. So this should be equal to log base 3 of 8. Wait, no. What's the matter with me? I'm doing this backwards. Let's go ahead and say it was log base 9. Okay? So if I wanted to rewrite the 9, right, I could say 72, right, divided by 8. Okay. That should be less stupid, right? So, well, maybe. I don't know if the calculator is going to work with me or not. Okay, so let's see. So if I do log base 3 of 9, I should get 2, right? So log base 3 of 9, I get 2. So according to this quotient law, if I do log base 3 of 72 and I take away from that log of the same base, so of 3 of 8, right, I should get also 2. And holy dog crap, I do. Okay, so this absolutely checks out, right? So that does it for the laws of logarithms. This is probably the longest video on this whole chain of videos. But anyway, if you have any questions over any of these, shoot me an email. Otherwise, you know where to find me. Goodbye.